Very good morning, students. In today's class, we are going to study the applications of the op-amp as a differentiator and comparator. So, in a differentiator circuit, we can observe the output is the differentiation of the input voltage Vin. So, the construction of the differentiator circuit using an op-amp is shown below. So, the construction is made such that an input voltage is applied across the inverting input terminal through the capacitor C, and for the inverting input terminal it is grounded, and there is a feedback resistance RF which is connected between the node A and the output terminal V0. So this is the construction details of the differentiator. And from the circuit, the potential at node B can be written as VB, which is equal to 0 as it is connected to the ground. And using the concept of virtual ground, we can say that both the input terminals are at the same potential. So using that concept, we can write VA is equal to VB is equal to 0. And the current which is flowing through the capacitor can be named as I1, and the current which is flowing in the feedback path, it can be taken as IF. So let us write the expressions for I1 and IF. So I1 can be written as C1 into d Vin minus Va divided by dt, which is equal to C1 into d Vin minus 0, as the Va is equal to 0. We have taken C1 into dVin divided by dt alone. So I1 we are getting as C1 into dVin divided by dt. And let us write the expression for the feedback current IF. So IF is nothing but the voltage difference between the node A and the output terminal V0. So IF is equal to Va minus V0 divided by the feedback resistor RF, which is equal to, as Va is equal to 0, let us substitute Va is equal to 0 and simplify, we will be getting IF is equal to minus V0 divided by RF. So IF is equal to minus V0 divided by RF. And the other assumption what we have made is the output current, the op-amp input current is 0. So I1 passes through RF as IF. Hence I1 is equal to IF. So let us equate both I1 and IF and we'll find out the expression for V0. So here let us by simplifying, we are getting V0 is equal to minus RF into C1 into dVin divided by dt. So if you observe this equation for the output voltage, it is nothing but it differentiates the input voltage. Hence it acts as a differentiator. And also the parameter minus RF into C1, it is the gain of the amplifier. So I can conclude that this circuit differentiates the input voltage Vin, and the gain of the differentiator is RF into C1. So thus this circuit acts as a differentiator. So the last application of the op-amp, it is a comparator circuit. So what is a comparator? So the op-amp comparator is nothing but it will compare the one input voltage applied at the inverting input terminal with the other input voltage which is applied at the non-inverting input terminal. That is, it is going to compare both the voltages applied at the input points. So here the circuit is made such that there is an input voltage applied across the non-inverting input terminal as Vin, whereas for the inverting input terminal there is a reference voltage V reference which is kept as constant. So now I am going to compare Vin with V reference. So based on that we are going to assume the output voltages as V0. So here if the Vin voltage is less than the V reference, the output voltage will be equal to the saturation voltage minus VCC. That is, whenever the input voltage is less than the V reference, the comparator output will be equal to the minus VCC. So in the right hand side I have shown the graph. That is, when Vin is less than V reference, the output voltage will be at minus VCC. Now I am increasing the input voltage, and if the input voltage Vn is greater than V reference, the comparator output will be saturated to plus VCC. So again it is shown in the graph as plus VCC. So thus I am comparing the input voltage with a reference voltage, and I am concluding if it is greater than that, it is going to be at plus VCC. If it is less than the V reference, it is going to be at minus VCC. Thus, if you again reduce the input voltage Vin so that it is slightly less than the reference voltage, the output voltage again it will swing back to the negative saturation voltage, which is acting as a threshold detector here. So thus we are able to compare an input voltage with a reference voltage. Hence it performs the operation of a comparator, and this V reference can be changed based on the applications, and I can conclude that this circuit acts as a comparator. That is, it compares the reference voltage. If it is less than that, it is going to be minus VCC. If it is greater than that, it is going to be plus VCC. And the corresponding output waveform also it is shown in the right hand side. So this is about the applications of the op-amp. So far we have learned all the applications of op-amp, starting from as an adder or summer, comparator circuit, differentiator, integrator, and voltage follower also. So these are the various applications of the op-amp. So thank you students. Thanks for listening. Thank you.